We don't really talk about climate change anymore. We need to talk about a climate crisis. Carbon dioxide levels just keep on rising, and we've already crossed our first major climate threshold. This means finding ways to deal with excess carbon dioxide has never been more urgent. But there's actually something quite interesting. The Earth already has a natural way to remove excess carbon dioxide from the atmosphere. Over long periods of time, through some reactions, the carbon dioxide can react with rocks and turn into stone, locking the carbon dioxide away permanently. The only problem is we don't have millions of years to wait. So we need to ask, how can we speed this up and make it more efficient? One exciting example is a project called Carbfix, which is based in Iceland. They take carbon dioxide from their geothermal power plants, dissolve it into water to make something called like fizzy water, I like to say, and inject this fizzy water deep underground into rocks such as basalts. And over time, such as within 2 years, this carbon dioxide reacts with these rocks to form carbonates. And essentially, the carbon is locked inside the rocks. So that's amazing, but there is a catch. Australia unfortunately doesn't have the same rocks as Iceland, and if we want carbon mineralization to work here, we need to understand our own geology. So I use computational chemistry, and I like to think of myself as a bit of a detective, as instead of running experiments in a lab, I use a supercomputer to really zoom in and see what happens at an atomic level. I study how Australian minerals like olivine, pyroxene, and serpentinites interact with the carbon dioxide and its derivatives and water. By combining quantum chemistry and machine learning, I can understand the very first steps of carbon mineralization, such as how does carbon dioxide react with the rocks? How do these reactions even begin? And how do the minerals dissolve and release the cations to actually form the carbonates? So you may be thinking, why does this all matter? Well, if we want to have permanent, safe carbon storage at scale, we need to get the chemistry right before we drill, inject, or even have a pilot study. My goal is to help turn Australia's rocks into a reliable climate solution. By understanding the science at the smallest scale, we can make a massive impact.